everyone. I'm Edoardo, I'm a product manager at Canonical, and I've been in the company for 3 years and a few months now, and I'm a product manager in the devices practice. And today I want to talk to you about Ubuntu for real-time systems. And before we go into the Ubuntu specific parts of the presentation, let's focus on the real-time systems first. One way to think about a real-time system that I like to use when explaining to partners and prospects is as a system with well-defined fixed time constraints. So there's a very clear upper boundary of time by when a certain operation, a certain workload on your system has to be computed. The idea is that you must be able to perform whichever operation you may have in your system within this upper boundary of time. And what's really important is that if you fail to meet this requirement, if you fail to meet this fixed boundary, you don't just have degradation in your system, you often have failure. The entire purpose of your system, of your operation, is essentially out of the picture. If it was just about degradation, you could go with a lower latency type of system, but you wouldn't be interested in real-time capabilities. Accordingly, there are, I think, two key features of real-time systems that are very important. One is achieving lower latency, because often if you have an upper boundary, you must also reduce the latency by when you must perform the operation. But even more important is having the deterministic response time, having the guarantee, the proof that you must be able to perform your operation within this deadline. So these two concepts accordingly inform where we find real-time applications in production. And this is just a brief overview of some of the key verticals, use cases, and scenarios where in the market we see deployments of real-time systems. One of the key segments for Canonical's real-time operating system is industrial. And industrial, both for discrete automation, but also for process automation. We often see, for instance, PLCs, programmable logic controllers in an assembly line that must be able to perform a certain operation within a certain upper limit. And if that operation on the production line is not performed with exactness up to the certain microsecond threshold, you're going to have the entire delay in the production line and failure with accordingly increasing cost in your entire system. So industrial, if you are operating in that vertical, is very important, the concept of real-time systems and taking advantage of an open source operating system for real-time capabilities because it ties well to the market trends that we see in the industrial space. In particular, if you come from that sector, you know that I'm referring to what is often called the IT-OT convergence, if you're familiar with these different trends that we see in the market, or Industry 4.0. The idea being that you can use the same technologies, the same tools, the same security updates, and the same maintenance guarantee that comes from your desktop environment all the way to devices down at your factory floor. In that market trend, we see the usage of real-time system on open source operating system like Linux and Ubuntu playing well into this trend. And this is one of the reasons why industrial, in the past few years, is becoming one of the key market focus areas for Canonical and for our real-time offering. Other than industrial, we also see a lot of use cases in the telco operations. If you think, again, about the definition of having to perform a certain operation within an upper boundary of time, you could imagine sending data packets across your telco towers in order to reduce delays in your network. If you are in a stadium, if you're operating a stadium and there's a big, important sport event that you want to stream without delays across your entire network, that's when real-time capable operating systems come into play. And in terms of market trends, what we see is the virtual function operations that are taking root in the production environments of telco operators. So if you operate in telco, you know about Open RAN deployments. And with Open RAN deployments, where RAN stands for radio access networks, often they're relying on real-time capable operating system in order to reduce the latency and the bandwidth of their streaming situations. There are many more use cases and verticals than the ones listed here, but also automotive. We are seeing lots of traction in the space for real-time capable systems, in particular when it comes to human-machine interfaces, when it comes to infotainment, or even some ECU applications in the automotive sector where real-time systems play a role. And going back to the definition, the idea of performing an operation, computing your workload within an upper boundary of time, you could then think of all sorts of other applications. Recently, we were talking with the prospects about high-frequency trading in finance. If you think about the idea of reducing latency, of being extremely quick in a microseconds range in order to process information and send a response back, that's where real-time capable operating systems come into play. But if we know the definition of real-time system at a clear level, and we see where it takes place, in which verticals real-time systems gets deployed in production, how do we achieve real-time in practice? And it's important to remember the idea of a system, and by system I mean a hardware plus a software stack. No single components of the stack, from the hardware layer to the operating system, to the user space applications, the networking layer, every single component of the stack has to be optimized in order to take advantage of real-time capable behavior. If you have a perfectly fine-tuned operating system, but you have a latency sink in your hardware, you're going to lose all of the advantages that you gain from the operating system level. We will see in a second how real-time Ubuntu, by partnering with the hardware vendors, with the network operators, etc., can give you that stack out of the box. But for a second, let's focus on the operating system level, while keeping in mind that this is one slice of the picture, and the rest of the stack, the rest of the system is also very important. The key idea at the Linux level, at the operating system level, is being able to interrupt whichever process may occur in your operating system, in this case we have process A, with a higher priority process that may come along in your system. So in this scenario, if you have the guarantee that a higher priority process, in this case process B, has to be performed within, say, 0.1 microseconds, you must be able to interrupt process A and assign the CPU to process B. Only once the process B is fully completed, once you have the guarantee that the process has been successful, the workload has been taken care of, you can then resume with process A, which was the lower priority process. Of course, this is a simplified picture. We're talking about a kernel, an operating system. There's a lot of technical details going into behind the scenes, but this paints the picture of what is actually happening at the operating system level. Now, imagine you were not be able to perform this type of operation. What would happen? Even if process A was extremely short, a few microseconds, if, let's say, at the cost of simplifying, you need to use a brake on your car because a person is crossing the road, you're operating your car, what you must be able to do is to interrupt whichever other process may occur within your system in order to take care of the higher priority process. Even a few small microseconds delay could have catastrophic consequences, whether it's in industrial, in telco, in automotive, or in any other type of vertical. And this whole situation here is what we call preemption in the Linux operating system world. And preemption, which stands for essentially preempting a process, interrupting a process, together with other changes in the scheduler of the Linux operating system and other lower level details, is what gives your operating system real-time capable behavior. Now, how do we translate that high-level picture in practice in the Linux operating system world? Now, Linux, one of the reasons for its widespread success and adoption is that it can serve a lot of different use cases and scenarios. Whether you are a bank, an enterprise operating with the confidential data, you need a certain type of requirements, which are very different from a developer or a student performing a simulation on their laptop. The idea of Linux and Ubuntu is that you can serve those different scenarios and requirements. Accordingly, in the real-time world, Linux has different what we call preemption models available. So there are scenarios where low latency, upper boundary of time is what you really care about, reducing the jitter of your system, reducing the latency of your system. But then there are other scenarios where that is not as important, but rather throughput is more relevant than lower latency. So it's sort of a balance between low latency and throughput. It's a trade-off that we see when talking with prospects. And accordingly, the Linux operating system has different models that you can choose in order to give you different results, in order to meet your different requirements. To give you an idea, preempt none, let's say, is the original preemption model of the Linux kernel. It's the first that Linux started using when in the 90s it was being developed. And preempt none is usually used for server workstations. And if you think about this scenario, where latency is not as relevant, but throughput is more important, you can think of use cases like a scientific computation. You want to do weather forecasting a few days from today. Here, simplifying, is not as relevant to have an answer in 100 microseconds, but rather maximizing the raw processing power. You're running your AI model. You need to give all the possible power and CPU and memory to your model in order to get to an answer. But the latency is not as relevant for this specific use case. So whether you are doing a simulation, a weather forecast, or want to maximize the power of your system, you would go with that preemption model. One thing that the Linux community and the Ubuntu community noticed is that this is not the only scenario where you want to run your Linux operating system. There are cases, let's say a desktop environment, where you want to have a quick reaction to the inputs of the user. If you open different tabs, if you switch to different applications and apps on your system, to have a smooth experience, besides the UX and the nice UI of your system, you also want to have a very quick reaction to your input. You don't want to open a new tab and then to wait a couple of seconds because you have so many tabs open that your system is overloaded. In order to get that guarantee, in order to reduce the latency, a Linux desktop system uses a different preemption model. And what this preemption model does is, to going back to the picture of before, in various areas within the kernel, is able to interrupt the CPU to assign it to a higher priority process so that it will give you a quicker interaction. Can we go further than that? Can we further reduce the latency? The user input is what a human may be able to notice, right? It's a third of a second, I suppose, when I open a new tab. When I start to get a bit frustrated, it hasn't yet started. But there are scenarios like embedded devices at the edge when it's not about a third of a second, it's about a tenth of a second where your operation has to be computed, where your workload has to be processed. In those scenarios, you would go with a different preemption model, which we call preempt in the Linux world. This is devices at the edge, this is your industrial devices, etc. And what preempt is doing is to giving more capability within the Linux kernel to interrupt the current process and prioritize the more urgent one, which have a more important use case at hand. This is the picture that was true of the Linux world and community up to essentially a few months ago. So you may be aware that we can do better than that. And the Linux world uses a set of code which we call Preempt-RT. Now, what I was describing a second ago, preempt none, preempt voluntary, and preempt, are part of the Linux kernel. If you go on linux.org and you download the Linux operating system, it will come with one of those different preemption models. But up to a few months ago, if you wanted to do even better, if you wanted to have the guarantee of decreasing time, if you wanted to have the certainty that your assembly line will not miss 100 microseconds operations, or your telco tower will not result in delay for your streaming of your devices, you would go with Preempt-RT. And Preempt-RT is a set of patches. It's essentially code changes that the Linux community, that the Ubuntu community, that the open source community has been worked on in order to further reduce the latencies of the Linux kernel. And together with the ability of preempt a task, there are a lot of changes that Preempt-RT brings to the Linux operating system. In particular, it changes the scheduler from the default one to one that is priority-based. It changes if you are more familiar with the technicalities of the Linux world. It changes the mutexes with ones that are aware of priority inheritance. Essentially, it does a series of technical changes to give Linux real-time behavior. There was a caveat, though. These Preempt-RT patches sort of clash with the Linux kernel. They were very intrusive. They were outside of the Linux kernel. And up to a couple of months ago, they were maintained as a separate set of patches. And this was a project that was started a few decades ago. Almost as soon as Linux got its way and became more widespread, developers, open source developers, started working on Preempt-RT patches. And almost a month ago now, or a few weeks ago now, you may have heard that the Preempt-RT set of patches were fully merged into the Linux kernel. This is the upstream Linux kernel, the one that Linus Torvalds and the Linux maintainers contribute to upstream. And today, Preempt-RT is part of that kernel. What that means for you as users of a Linux operating system is that a lot more developers, a lot more security guarantees come into Preempt-RT because thousands, if not millions of people have reviewed the code, have deployed the code in production, and it has been a decades-long effort to get Preempt-RT into the upstream Linux kernel. So today is not a separate set of patches, it's not a separate standalone code changes that you want to add to your Linux kernel when deploying an embedded device or an automotive use case to achieve real-time behavior. Today, they are part of the Linux kernel directly. This Preempt-RT set of patches is what gives Linux real-time capable behavior, and is what Canonical uses in its own real-time Ubuntu operating system. But I do want to go back to this idea that I mentioned at the start of the presentation. How low can you go with a real-time operating system? And by low, I mean how much can you reduce the latency? What is the lowest limit? What is actually the highest limit, the upper boundary of time by when you can have a guarantee of performing your workload or computing your in-kernel processing? The short answer is that I don't want to give you a single number because that would be the wrong answer to the question. The wrong answer because we are looking at a series of stacks and layers in your entire system. Whether you're operating in aviation or in automotive or in telco, etc., you must take care of the hardware and the firmware that is running on top, the BIOS or the bootloader, and the operating system and the user space applications and networking that is on top. If at any point within the stack you have a loss of latency or a loss of jitter, your optimizations done at any one of these layers will be essentially useless. It is really a point that I want to drive. There is not one single upper boundary of time that the real-time OS like Ubuntu can provide you if on your hardware you're losing all that advantage, if your user space applications are not real-time optimized. And why is this relevant? This is relevant because, yes, you could use Yocto. There was a question about Yocto earlier. You could go with recipes and layers if you are familiar with the Yocto world, besides the steep learning curve that it would come with that. But if you're running Yocto and the user space applications on top are not real-time optimized, or the hardware on which you're running doesn't take advantage of the Preempt-RT set of patches, essentially, if you want to go to production on your own by only taking care of the operating system level, you did hire your Linux kernel engineer in your company, and you think now that's all you have to do to take care of real-time systems, that would be wrong. That would be incorrect. You do need to take care of the hardware and the user space and the networking layer. So you do need to partner with an enterprise that would be able to give you the advantages at each of these different layers. And one of those enterprises that works at each of these different layers is Canonical with Ubuntu. This is why at the start of the opening remarks, Joe was mentioning how we have partnerships with ODMs and OEMs and silicon vendors. Sure, we do it to have a channel to get us to production faster. If you buy hardware from NVIDIA and Ubuntu is already there, that's a great win for us. But the actual reason why we do it is so that we can partner with NVIDIA. We have our engineering team working with their engineering team so that Ubuntu on NVIDIA takes advantage of NVIDIA's own optimizations, in this case for real-time behavior. When we work with AMD and with Intel, it's so that AMD CPUs take advantage of Ubuntu's real-time capabilities, so that when you go to production running real-time Ubuntu on Intel, you now know that out of the box, the operating system is taken care of for real-time capable behavior, the hardware is taken care of, and why? Because our engineers work with their engineers to do the optimizations, the user space applications which are covered in the bundle and included with the Ubuntu Pro subscription, and networking because we partner with the network vendors, etc. So the summary here, the idea is that there is a reason why, from a strategic point of view, Canonical wants to work within the ecosystem with the OEMs and the ODMs and the hardware vendors, because we understand that there is no standalone operating system. If you are just an hardware vendor, good luck with that. You're selling silicon, you're selling pieces of hardware, but if your operating system on top is not fine-tuned and optimized, there is no added value to your end user, essentially. This is the message that I want to drive with this slide. And in terms of which silicon vendors we work with, which OEMs and ODMs we work with, some of the logos are listed here, but probably the ones that Joe was showing at the start of the presentation are more representative. It's essentially a long list of the key silicon vendors in the market. But it's not just the silicon vendors or the OEMs and ODMs. There was a question about the cloud. Well, what we do there is to partner with Google Cloud team, to partner with the Azure team, et cetera, all the hyperscaler and the cloud builders, so that you can run real-time Ubuntu on the cloud, the same real-time Ubuntu on the cloud that you will run on your server workstation. And why do we want to do that? Is so that you can take advantage of real-time capabilities while maybe your hardware is not yet available. There was, I think, 1.5 years ago, probably by now it's over, the chip shortage, right? It was in everyone's mind, everybody was talking about it. So if there is a chip shortage and you are an automotive manufacturer, a tier 1 supplier, you don't have access to the hardware, what do you do with your developers? You just keep them there waiting. You start developing on an hardware that is going to be different than the one you want to production because you don't yet have access to the hardware. And it's not just about the chip shortage. It's about now there's a geopolitical ban on semiconductors can be sold to China or Taiwan. We are all aware of that story. What it means in practice for you as a manager or as a developer is that you may not have access to the hardware as soon as you want it. There may be delays by when you get your hands on the hardware. But what you can do if you have real-time Ubuntu, the same operating system on your desktop and on the server and on the cloud, it means that you can start development today while you don't yet have access to the hardware because you are operating with real-time on the cloud. And once the hardware becomes available, then you can use the same code that you wrote, the same optimizations you add in your operating system, the same hardware tuning and advantages can be directly transferable to your day-to-day development. So the idea is that when we showed, Gabriel and Joe showed Ubuntu Desktop and Ubuntu Server and Ubuntu Core, to that picture I would add and the silicon vendors and the clouds. Why? Because now you don't have to be in the world of 15 years ago where you do development on, let's say, Ubuntu, and then when you go to production, your device is actually running Windows, and when you talk to the cloud, your device is talking to Red Hat, let's say, operating system. That world is a big mess. It's painful. Why? Because these different operating systems don't talk to each other. The applications that you did on Windows may not run on the Linux Red Hat version, and there's a bunch of dependencies and lack of interoperability between the three. But if you can use Ubuntu on the desktop and Ubuntu on the server and Ubuntu on the device in production, the one with small memory requirements that is running Ubuntu Core, and when you send the data to the cloud, it can be analyzed because the cloud is also running on Ubuntu, you have a win because you reduce the development time, you accelerate your time to market because it is the same software, it is the same operating system that runs across all of these different stages. And this story, which applies to the broader Ubuntu family, also applies to the real-time Ubuntu version of our operating system. Because real-time Ubuntu, you can run it on different hardware, and you can run it on it's also in the AWS marketplace. You can run it on different clouds. So you can start today to do your development in the cloud, even though you may not yet have access to the hardware right now because of whichever shortage of exogenous factor that you do not control just yet. So you don't need to change your plans. You can start development today. And real-time Ubuntu is a standard Ubuntu operating system, is an Ubuntu kernel, with the addition of the Preempt-RT set of patches integrated into it. So it's standard Ubuntu, by which I mean the familiar developer environment, the thousands of software packages that make an Ubuntu distribution, plus Preempt-RT. It's not as if you can run Python and CUDA and ROS and all the other applications that we were looking at a minute ago on Ubuntu, but not on the real-time version. No, it is the standard version of Ubuntu plus real-time behavior. It's simply, if you're operating in scenarios where real-time behavior is important and necessary, where you must have an upper boundary of time, that's the answer for you. It's an LTS kernel, and LTS means long-term supported, which means up to 12 years. It will receive security fixes, bug fixes, CVEs, and maintenance by a team of expert kernel engineers at Canonical. So if you're using Yocto today, what do? You need to staff in-house kernel engineers, which need to be experts at maintenance of your Yocto image. Not only they need to be experts, like Gabriel was saying, when you have your device running in production in Malaysia, what do you do if your headquarters are in London? Do you send a field engineer to manually fix and reboot the device? Of course you aren't going to do that. So what do you do? Well, when I ask prospects at Embedded World or Hannover Messe or any of these conferences, what they tell me is, well, we just don't update the device. Like, I will not risk breaking my device in production. I will just keep the version Windows 10 that is about to be end of life, and good luck to me. I will not take advantage of any over-the-air updates because I am too scared. You can go with that approach, but I think there are two reasons why that's short-sighted. For one, you can't take advantage of the latest innovations and optimizations and open source inventions that get built by the community. Whether it is your customer now wants access to an LLM, let's say, at the edge. You were running the previous version of the operating system that you are afraid to update, and the most recent version of the operating system now claims to have LLM support. You can have your Edge AI model running. You are too afraid of updating the operating system, so you will not have access to that latest innovation. You will not give that to your customer. Accordingly, maybe not today, 3 years from today, you may be out of business because you are not keeping up with the market. You are not keeping up with the trends and the development. So that's one reason, having access to the latest tools, the latest innovation. If that's not enough for you, well, $5 million fines that Joe mentioned from the CRA, that's also important. Now it's not just it's good business for you to stay up to date. Now it's if you're not compliant, you have a fine to pay. The CRA in Europe, there was a similar act that the Biden administration was starting in the US. If you don't keep up to date your operating system and your device with the latest security fixes, you also risk a fine. So LTS, this acronym means compliance and security and access to innovation and long-term support and staying competitive in the market. And we do that for you for up to 12 years. Where do you run real-time Ubuntu? Again, wherever you have your hardware, whether that's an Intel-optimized version of the hardware, whether that is on the cloud, whether that's ARM or x86. The reason why Canonical has these strong partnerships with the OEMs and the ODMs and the silicon vendors and the hyperscalers and the cloud builders is so that you can take advantage of the entire ecosystem and you're not stuck in a silo on Azure. You are not stuck on your current developer workstation that 5 years from today will be outdated. We are in the open source ecosystem, and we've been having a role at it in the past 20 plus years because we can, with open source, take advantage of the latest innovations. NVIDIA, which now is a $1 trillion company, 10 years ago wasn't so big. And 5 years from today, there will be a new hardware vendor, there will be a new GPU vendor that claims to do AI at the edge with their new hardware. And if you're running your old Windows, how will you take advantage of that new hardware? Well, if you're running Ubuntu, today you have the assurance that you can run it on NVIDIA and on MediaTek and on Qualcomm, and whichever new silicon vendor or cloud builder or new fancy startup will be around 5 years from today, Ubuntu will still be there. That's the reason why we partner with all of the silicon vendors. That's all I wanted to talk about today, so thank you for listening. If you have a couple of questions, I'm happy to take them. Could be on Realtime or anything Ubuntu or Canonical related. I'm happy to cover other topics as well. Sure, please.
Do you have to enable the Preempt-RT? So if I update my kernel 6.12, do I need to enable anything, or is it out of the box?
It's excellent question. So the question is essentially, how do I access this? If I am running 6.12 kernel, do I have to update it? Do I have to reboot it? The answer is no, it's pre-integrated. Real-time Ubuntu, and you can find documentation on how to enable it online. You can find a lot of material covering the topic. Includes, by default, the Preempt-RT set of patches. How do you get them? You pro-enable real-time Ubuntu on your Ubuntu workstation. It's one single command. You don't need to integrate them yourself. There is no multiple accesses and multiple commands. You pro-enable. And why is it behind the Ubuntu Pro subscription? Because it is not just about the operating system. Ubuntu Pro, as we saw, gives you access to security coverage, to user space applications, and to the hardware optimization. So the reason why, in terms of distribution, real-time Ubuntu can be accessed by the Ubuntu Pro subscription is because Ubuntu Pro includes all of the rest of the optimizations and the work we do at the stack. So Ubuntu Pro is one subscription which gives you access to what Joe was mentioning. We give you real-time performance, we give you compliance. What it means is we update the user space applications and we include the FIPS module that gives you compliance with the FedRAMP mandates, and we give you the real-time Ubuntu operating system, and we give you the hardware. It's all within the Ubuntu Pro subscription. With that, I think I want to give the word to the Ocado partner presentation. So thank you very much for listening, and enjoy the rest of the day.